So a little bit of review, because we're going to continue to build on this on seeing how cities form is our objective with this chapter. So we had...
Are we in chapter 2 right now?
Yeah.
Yes. So if the gain from trade was a couple shirts for each one, we said, well, wait a second, what if it takes time to trade with each other? We're not going to trade if the transaction costs exceed the gross gain, right? So that's kind of what we came up with. And so in the north, they could do 6 shirts per hour. So we got to be less than 20 minutes for them to still have a positive gain. And it's a little bit different down south because their time for 2 shirts was different. All right, so that was our premise then of kind of taking this to a different level than what we'd seen before, is thinking about transaction costs and transaction and time to do. All right, let's see. I think we did this one maybe. Did we get to this one? I guess it doesn't matter. Give it a read. It's just kind of quick comments here on how places might start to organize based on that travel time is where we're going. Cadence?
These are all on Blackboard, right?
Not currently. I can't remember with this class. I'm going to get them to you either Blackboard or email. All right, so ultimately this is going to drive changes in land prices to operate close. So we've had cities start to be created by canals, railroad. The evolution has changed after technology changes. So then you start to see new cities popping up. And what did we learn about sunk cost? What's the deal with sunk cost in econ? Do we care about them or not?
Well, they're there no matter what.
They're there no matter what.
You can learn from them, but
Don't take them into account at the margin, right? So they're still there. Yeah, you have to either you prefer not to have them, but once you've committed to them, that's the sunk cost it is. Once you've committed to them, you can't avoid them. So they're not avoidable. So as far as moving forward, where I wanted to go with that with the development of a city is to think about if you've built up a city around a shipyard, a port, and technology changes such that rail starts to develop or freeways. The city now has built up a lot of other things there that are now existing, and so it still might be advantageous. The marginal cost of developing that city a little bit further might be less than the marginal cost of starting a brand new city. And so you might start to see connections to those railroads to begin with. So it's kind of similar in a sunk cost law. You see some old big cities continue to grow, maybe even after technology's left them, because the marginal cost to change them is less because they've already existed and had some other things develop as they went.
Plus they have the labor force aren't there.
They have what?
Plus they already have the labor force there.
Yeah, the labor force is there. Yeah, a lot of these things tend to be sticky, and once it's there, then there's a real cost to move it potentially, and so it might be better to just relocate something in that spot. So circumstances change as we go. All right, so this is I think the last one we left off with was to say, what if we have a factory instead of home production? So we started off with home production, and what if we can shift production into a factory, and this would be for the South, right? So the South, remember, was 1 and 1. And so now if we developed a factory, because of having some economies of scale, we're going to drop our constant returns, and we're going to get 6 shirts per hour. Still 1 loaf, so we're not going to change that. So all we're going to allow is shirts to have something about them that allows them to be more productive in a factory setting where we can take advantage of those Adam Smith specializations. Prices adjust to ensure locational equilibrium. We had 5 axioms. Anybody happen to remember what that axiom is? Chelsea? She held up this, so she silently said, so 1, that's right. All right, so we've got price adjustments that are going to go on. to ensure a locational equilibrium. If a city is 50% more than a rural living area, which is just one loaf in the rural area, what does the wage need to be? If it's more expensive, we've talked about cost of living and stuff. So if it costs one loaf, it's 50% more. What does the wage need to be? The wage will need to adjust for that factor. What would the wage need to be in terms of loaves? It's not really a trick question. 50% higher. 1.5. Okay, so we got wages will be 3/2 of a loaf in the city, but maintain only being one loaf in the county or whatever you want to call it in the rural area. So let's add in some capital. What if there is some capital that costs 1/2 a loaf at the factory? So what is the total cost per hour now to produce a shirt in the factory? You've got the labor cost. Labor cost is a little higher in the city. And now we're going to run 1/2 a loaf for some machines and some special equipment at the factory. So what does it cost per hour to produce a shirt? 2. 1/2 plus 3/2, right? Okay, so we've got labor, capital, total cost. Remember that the cost per shirt with 6 shirts produced per hour was 1/3 of a loaf. That's what we came up with before, right? That was the opportunity cost. So if the cost per shirt, now taking into account the productivity, so we got 2 loaves per hour, 6 per hour can be produced, right? So we're trying to track down what the cost is for each shirt. We're talking 1/3 of a loaf. So we're mixing together kind of the marginal product times the marginal revenue, in a sense, right? So the cost is 2 loaves per hour, considering labor and machines, which gives us 1/3 of a loaf as the cost per shirt, since 6 of them can be made per hour. All right, so 2, kind of the average cost, 2 loaves divided by 6 gives us our 1/3. That one's a little bit slippery if you go back to review that. If it is a cost of 1/3 of a loaf, what is the expected price in a market, competitive market?
1/3.
1/3. Why?
Because if you're saying in a competitive market, there's no economic profit.
Okay, so economic profits are 0. So we'd have 1/3 of a loaf. We're going to do some additional exercises to just think about that being 4/12 of a loaf. All right? So this is upcoming here. So 4/12 equals 1/3. Just think of that price. 1/3 of a loaf of bread is the cost of a shirt. All right.
Quick question.
Yep.
How did we get the labor cost? That's the opportunity cost, correct, for the individual?
Yes.
Okay.
So we had to pay, in order to induce that person to work for our factory, we needed to pay them 1.5 loaves instead of 1, because it's more expensive to live in the city. And that was an assumption of the model, that it's just 50% higher. So we kind of dropped that out of the sky on us and said, suppose it's 50% higher. Okay? So that was to induce them to come to work there. We're holding, there's other things that I'm kind of skipping over, but ask questions as you go. We're holding the utility level constant. We got an equal, it could be the same person, right? So utility's constant between there, the same identical human being. What you're living out in the county now, what would you need to come to the city? And so if living costs are 50% higher, and you don't care about living in the urban jungle, we're not taking into account that you like smelling the fresh air and the cow poop and stuff living out in the rural area, right? So we're kind of holding constant all that. We're just lumping it all into this 50%. So market area. Suppose that it costs the consumer, so we're on the demand side, 1/12 of a loaf to get to the factory. What is the net price to the consumer who lives 2 miles away? So what's the price going to be? What was the price? 1/3 or 4/12 plus 2/12, 6/12, was a half. Okay, so now we're tacking on this transportation cost to get to the factory
So it's
to
a
buy.
half a loaf is the cost?
Is the net price. Yep, is the net price. Because we've got the real cost, the sticker price, but then you got to drive to Walmart and spend some gas money to get there. That's all we're capturing. But we're putting it in the form of these loaves. What's the max distance they can live so that it's still better to buy factory shirts?
8 miles.
How much?
8 miles.
8 miles, right? So 4/12 is the sticker price. If I live 8 miles away, I've got 8/12 worth of transportation costs. Altogether, it's going to cost me 12/12, which is one shirt, which is what it costs me to make it on my own. So we're back to self-sufficiency.
Does that make you indifferent?
Yeah, it makes you indifferent. At that point, that's your point
so
of
wouldn't
indifference.
it only be 7 then? So it's better to buy the factory
Well,
shirts
we're-
rather than being indifferent?
We're not going to get into the kind of discrete units, but yeah, that's your kind of break-even point. Yep. Okay. All right. So here's our martini glass. This is one of our models that we're going to work with. So what's going on here?
Oh, you're like, what?
So the vertical height, you can see the martini glass here.
Did you call it?
Not that I always have to bring beer and pizza into every.
Oh, this isn't. That's not.
So
big,
now
so
you
you're
see,
good.
you see how you've
No, we're
escalated
actually-
in. You're in higher level classes. This
So
is
we got
martinis
classy
now.
stuff,
So we're doing
man.
cocktails now.
We're not just in beer.
All right.
All right.
Chicago style
So
pizza, too.
distance to the factory, right? If you live right on top of the factory, then the cost of your the cost here is in just the price, the sticker price. As you start to move away from the factory, if you live 8 miles away, then you get to that point of indifference. So this then represents the market area for this production process.
So the 8 miles to the right of 0 is the same thing as 8 miles to the left?
Yep. Yep. So that's our space, spatial economics.
Is that
There we
just
go.
saying
We're-
like it doesn't matter if you live 8 miles to the north or
Yeah.
the west?
Any direction. So that's why I kind of had the circle on the first part. If we're looking top down, you can be in a radius anywhere around. So you've got an 8 mile radius that you're looking at. And that ends up being your market area. Okay, any other questions on that one? So you see the person with 2 miles, 6/12. This vertical height is the price to that consumer who lives 2 miles. So if you live 4 miles, this vertical height is your net price, taking into account the cost of the shirt, the sticker price, plus your travel. Cost of the shirt plus travel. As you live further out, the cost of the shirt, of course, stays the same. The travel goes up.
So the left arm of the tree is the same thing as the right arm of the tree. They're measuring the same thing.
Yeah. So that's the spatial part, because if we're looking top down, we're thinking about a circular area right in the middle, and that's where we would locate. So the radius. Okay. So if you're thinking about where to live, if you're making that decision, holding all of the things constant, where would you rather be? Close. So what is your prediction on land prices in this environment?
Closer you are,
The more expensive, why?
because it's convenient.
Okay?
No demand price, like demand's gonna be high, so.
Yeah,
Because,
but
well,
that's.
the
I want to
longer
think.
you
I want to
work
think
there-
more selfishly. I want to think more selfishly about the consumer.
The longer you work there, it's a single price to live there, and so pretty much, if you can
Okay.
efficiently have the lower cost than somebody who has to commute every single day longer.
All right, and John, did you have something to add?
I was just gonna say, people are gonna bid it up between the two, or between each other and competing for the same spot on land.
And how far are they going to bid it up to?
Until it exceeds
Wage they're,
the wage they're given, right? Yeah. Or the
So if you work in the factory, if you live 6 miles from the factory, or you live 1 mile from the factory, your wage is still 3/2. All right. So what changed?
It's the marginal cost
The
above the
commuting
cost of
cost.
insurance.
Commuting costs. So
Commuting costs to do what though?
to get to work.
But we're focusing on, we're kind of ignoring that for now, because we were buying.
So are we the worker or the consumer?
So on the consumer side, let's just focus on that for a second.
Oh,
The cost
I
to
thought
get a
we were-
shirt,
Yeah.
it's the
Cheaper
marginal
price.
cost above what it costs to get the shirt.
Okay, so the wage isn't going to change. We've already adjusted the wage for the rural versus city living. And so now what's going to drive the land rent is your ability to purchase that shirt. The closer you are, the more you can bid it up. So we can start to see now this gradient of prices, of land prices, from the center core, which is going to have the most expensive prices in our area. Which one's going to have the most expensive if we think of kind of a ring on a tree? The one's closest to the middle, right? So that allows people to bid up that price all the way up to the amount that they're saving by living closer. So we again start to see this locational equilibrium where land prices now, there's always kind of one degree of freedom of what's going to be able to go, and land prices are going to be the thing that's going to be bid up, potentially, as people relocate themselves. All right, so
What do you mean by bids up? Just meaning drives the price up, or?
it is it's a unmodeled phenomenon of they have room to negotiate the land price because relative to somebody else that lives further, they have more wiggle room because they'd be closer. And so they're going to bid up. There's other people that are thinking the exact same thing. And so you're going to have multiple buyers bidding up the prices of the land.
Think
That's
of an
closer.
auction.
Kind of like an auction, yep.
But my question is, on a higher price of land increases density. If the housing prices are increasing, wouldn't that scare people away to farther outside the center because they can't afford it?
Yeah, this isn't, I wouldn't even say this is,
Density of population, density of what is that? You know what I'm saying?
it's density of population.
Okay.
And so more and more people are going closer and closer, wanting to go closer. But these two things are more correlated rather than causal. So I didn't write this exact statement
Oh, okay.
until you brought it up. These are great things to bring up, by the way, but I would say these things would be correlated as movement comes in, it becomes more dense and prices are bid up. So those two things are going up together, not necessarily, oh, land's really expensive there, so I'm going to go move there, right? So we weren't thinking of that, but it's actually endogenous into the system that those things are happening together.
I mean, it can't, obviously it's not gonna be incentive worthy, but, there's not gonna be a bidding up effect if there isn't a high population density just because there's no one to bid up the land.
Right.
There's no-
Right. Yeah.
I have a question about, wouldn't they be indifferent between buying a cheap house far away and buying an
That's what locational equilibrium would be, you're right. So these equalizing factors then of where you move through competition is going to drive up land prices such that, again, in equilibrium, the consumers are indifferent between living in the rural area or living 8 miles out or living 2 miles out. That's right. So that's where equilibrium would be. As we talked about with equilibrium in entrepreneurial class, do we ever get there, whatever. So, but we know where it's at. That would be our prediction. Maybe there'd be some obstacles, and if it's always a dynamic process that's ever changing, blah, blah, blah. But that, you're absolutely right. Under a certain amount of restrictive assumptions, prices would adjust to make somebody completely indifferent between living 1 mile out, 2 mile out, 8 mile out. Okay, Michael?
I was just going to say, as far as like a simple example of this, a really good one would be actually the Steinway pianos and the factory that they have up in New York, where when Steinway came over and started creating their factory, everybody that worked for him actually created the Steinway Village.
Oh, okay.
And pretty much, I mean, it's a 3-4 generation
Yeah.
area where people are just working for the factory over and over again, and they haven't moved.
Right. Might even come back to that one. You made me think of another idea, but yeah, that's a good example of one that we're using here at the school, right? All right.
I think we're just using different axioms.
Yeah, we're gonna continue to kind of wave
Just trying to
through them.
follow.
Yep. So, and we use this one already. So, competition generates zero economic profit. All right, and we're gonna work on a problem here. Oops, we're not gonna do this one yet. I guess we could. Yeah, let's do this one. It's not too big of a extra step here. So, multiple martini glasses, the evolution of cities, right? So once we start to get outside of that distance, then we've got another factory that could do the same thing. And so now we start to get distance between factories with these cones, and we get multiple factories started.
So do the suburbs grow? And this is just an assumption by
Oh,
the intersection.
Katie? We're going to work through this here in a second. I'm going to just give this to you. Yep. Say that again.
Do suburbs kind of grow in those ideal intersections between the factories then, or?
Yes, again, this is a model,
Okay.
Lots of other things coming into it, but that under the assumptions that we've got here, we'd expect to see multiple of these. And that's why we see multiple cities, and the distances that they are from each other would be determined by factors like these. All right. Let's,
So what was the problem, just to figure out that they would all sprout out next to each other? Or,
right, what would cause there to be multiple cities? If we look at, so the question economists would look at, would say, here's the state of Kansas. And if we just turn on city density maps, you guys have looked at that with red, and you kind of look at why they are where they are. These are the types of reasons that we start to investigate why they form and the distances that they're at. Okay. You guys go ahead and read that. I think we're ready to hit the trading city example here. Okay, this is one of your back of the chapter problems. I told you that we'll be assigning those as homework too. This is number 1 we're going to do in class. It utilizes what we did earlier. But tweaks some things. So I'm going to change this to the document. Actually, I want to get this is Colby's. So go ahead and start talking with each other. Read the question. So consider the example in 2.1, 2.2. Suppose that a single number changes. We're just going to change one thing. The shirt output per hour in the north is 4 shirts instead of 6. Remember it was 6, now it's going to be 4. To specialize, a north household switches from 1 hour from bread to shirts, which is what they did before. Remember, they were endowed with 1 hour. And the south household switches their 2 hours from shirts to bread, which is what they did before. The exchange rate is now 3 shirts for 2 loaves. There are scale economies in exchange, and a transaction takes 30 minutes to execute. The gains from trade are blank for the north and blank for the south. Those gains are going to change. So go ahead and start working on that. And feel free to group up, talk to your neighbors, say what the heck's going on with this, what are you doing?
What the heck's going on?
Full blown no holds barred,
Yeah, I wasn't here.
collaboration,
Tuesday, so-
learning.
Oh,
Falling into
follow tape. Now John's got it. I see him writing something.
I'm kind of just making changes in the model. Not really all I was doing.
Oh, so we're
So yeah,
across the
I think it would be good to just go edit the table above for starters.
So how many hours do we give each one of them? North has 2 still, south has 4? Is that what?
Yeah.
I thought it was
No,
one
two
and
and two and one.
Okay.
2 to the south, 1 to the north.
Sure, output per hour in the north. Is 4 6.
I'm very confused.
1 hour.
It has to be a total of 2 and 4.
Three shirts for 2 levels. There's still some difference here.
I'm really confused.
Well, I've got the model changed.
How many?
So
how
that's
many
fine.
units
So
are we
remember,
already
it's this or this. So they spend 1 hour and they can have this or this,
at? Okay.
right?
Yeah.
Yeah,
South
but
has-
if you look at
That's the only
the,
thing we
And
flip
the south
flop.
has 2 hours, right?
And the
Yeah,
south has 2 hours. The north has 1 hour.
there's no way, because if they have 1 hour, then they can only make either this or this, and the point that they're giving at the start, and the only way we can find gains from trade is if
I
we
think
have,
that's what we did last time.
Yep.
well, I understand.
So
that.
calculate the gains from trade first. So
So
do
pretty
part
much the
do
north
part
is-
A first.
So I'm saying there's only one way we can have gains from trade, and that's if these people have 2 hours and these have 4, just so that we have actual starting points, because we would have the starting point of, in this case, like 2, 4, and then 1,
You're
2,
speaking some
2.
language right now.
In the end,
This
north is
did-
making 4 shirts and the south is
Yeah,
making
this
2 bread.
I'm not sure what you're doing here.
Yes.
Right? Right.
Oh, you're changing opportunity cost.
Yeah.
Okay.
Are they making 2 bread or is it just 1?
They're making 2 if they have 2
Oh,
units
that's
to
right,
live.
2 hours.
Which means opportunity costs are changing.
Yeah, so there's room for gains for trade, that's for sure. Anytime 2 countries aren't identical, if their productivities end up being identical, there's no gains for trade. As long as they're different, there's room to trade.
So the opportunity cost for bread on north stays the same because it's 3. But
Opportunity
Shirts
cost
change.
for bread.
this number didn't change at all.
No, you don't got this down. So in the north, 2 bread can be traded for 4
You can't
shirts
trade
now,
halves.
right?
Mhm.
So the opportunity cost of 1 shirt is
1/2.
1/2.
Right. But this number's not changing, that's what I was saying. Or is it?
Go back to these equation goggles every time. I swear I'd still do it because it can be a mind bender, I think, depending on how your brain is wired. But for me, I have to go back and do it. So the opportunity cost of 1 bread is 2 shirts. Right?
Yeah.
Okay, you gotta buy into that. That's a biggie. If you can't get past that, that's first base.
This is the exchange rate though now, right?
Yeah,
Oh,
the
the
exchange
home
rate
base.
changed. The exchange rate changed.
That's your.
Now you're still not done. You got to do the calculate the gains from trade.
Right.
Now, yes, you can do the graph. You know that they're going to specialize. You know where they're going to specialize in.
So for 1. So north's gonna produce shirts.
Yeah, North is still doing shirt. Yep, they got the opportunity cost. Yep. So that didn't change. North is going to specialize in shirts. But the max amount of shirts that they can make now is changed.
The max they can make is 4 now instead
Yeah,
of 6.
they can only make 4. So now, once you start to get comfortable, of course, you don't have to draw up the production possibilities frontier, but it helps. Surely helps my brain.
Right on the y-axis, I suppose.
Yeah, I think is that what we did? Bread on the line.
We're talking about gains in trade of shirts, correct?
Yes. I'm sorry. What?
Gains in trade for shirts.
Yes. Okay, so now they're going to produce all shirts and trade at the exchange rate that they came up with, which was 3 shirts for 2 loaves. So 3 shirts for 2. So the terms of trade, or the world price here, 3 shirts for 2 loaves. Let's see, what are we doing? Bread. So 1 shirt,
166.
the price of a shirt.
That's the
We're
one.
looking at gains from trade before transportation costs, correct?
Right.
Okay.
Yes, this is all, part A is just cranking out the gains from trade, no transportation costs, basically. You're just assuming that that doesn't exist yet. So then, if they give up one of their shirts, how much are they going to get? If they do it themselves, right? So if they give up a shirt, the price of a shirt is 2/3 of a bread. So then they're going to go up above their production possibilities frontier. So if you calculate what we did before, is we said that their starting place was at, what did you guys do for initial start?
4 shirts.
Yeah, 2
4
bread,
shirts.
4 shirts.
With their initial starting place?
I don't really know.
And then just
All I know
sort of
is
do
gains
one
from
and
trade
one.
are
Or
1.
him at
Right?
Well, the south would be 1 and 1, right? So that's what we did before.
But now they're,
And what did we do with the north before?
it's just all shirts.
That's where they're producing.
I'm confused about the
What'd you do, John?
Seems interesting math.
Can you check my answers? Is that correct? Part A?
Yeah.
And then.
Yep. So what did you do? How did you calculate that?
Because, I mean, looking at this, they're going to specialize in shirts,
Mm-hmm.
but they're trading, and that gives them where they would have been here with 0 shirts
Okay.
and 2 bread. Now they have 1 shirt and 2 bread.
1 shirt and 2 bread.
And now, instead of having 2 shirts after trading, 3 shirts.
Okay.
So there's that, but they won't develop because that's that.
Yeah, so we'll get to B. I want to get everybody on A. So yeah, Michael's got it. So did you guys get 1
I
and
guess
1?
I don't understand what you're saying about the starting point.
Well, you basically implicitly did the starting place at,
Specialization.
you went from 4 to 2, right?
Yeah.
Yes.
And you went on your trading line up to this point
Uh-huh.
to pick up 1 shirt,
Yeah.
right?
'Cause
2,
that's
3,
the only place that you can really,
to do it.
yeah.
So implicitly what you did is you said this is point A, this is point B, going back to autarky or no trade, trade, and then the gains from trade. So you're showing the gains from trade in terms of shirts, 1 shirt.
How'd you get 1 though?
Yeah, is it going back 3? Because
Yeah.
we traded 3
Going
Because if
back
you trade
3,
3
yeah.
shirts, then you get.
Remember,
2
you
loaves
have
of bread.
all shirts, so you're going to sell this many shirts and get back to having now in a position where you can have 1 bread and 4 shirts.
I have
Yeah.
a question. Like when we went over it on Tuesday, we started up, we had our starting point, like if they didn't trade at all. And so for the north, that would be 1 and 2.
Oh, it's 1
They make
shirt,
1
2
shirt,
bread.
or 1 bread and 2 shirts.
Right.
And so then what we did was like
So
what
for the
would they do
south.
to get back to the 2 shirts? Like how much would they
Right.
trade?
Right.
And so like, I mean, it ends up being fractions, but it, I don't know, it's different.
And that's why here we can put it all. If it ends up being fractions, if you do it that way. So in order to get it all in terms of 1 good.
Is that what you're wanting though, or are you wanting us to?
Yes. For this to show the gains from trade, we usually show it in 1
Yeah,
good or the other.
I just thought we were doing it with the math, so leave it there. So.
Okay, so we get 1 shirt each for each one. And is everybody all right there?
Could you go through that? Because I don't.
Okay.
Are you,
So graphically, we have 4 shirts,
I'm sorry.
and we're gonna sell 3 of them, right?
Where in the problem is to say that we're selling 3?
It's just the exchange rate is 3 shirts for 2 loads.
3 shirts for 2.
What is this?
Yeah.
For the south?
That's what.
No.
For anybody, yeah.
So for anybody, that was given to us, the world price, if we're thinking big trade here. So the price was given to us of a shirt is 2/3 of a bread, or 3 halves. So if I buy 1 bread, I give up 1.5 shirts. 2 bread, I get 3, right? So I'm snaking along here, and I'm going up, and I ultimately get 2. Giving me a gain, if this is my point C. So this is the consumption possibilities, this is the production possibilities.
Yeah.
And it gives us a gain of 1 compared to here.
Oh, because we weren't getting any bread when we were producing 4 shirts.
That's right. 4 and 0 here, 0 and 4, or 0 and 2 bread, 0 shirts and 2 bread here. These are all production possibilities, and so our gain from trade in terms of shirts was 1.
For the north.
Yeah. And actually for this problem, I mean, they didn't put the gains from trade in terms of one or the other, but we did shirts before. So you could put the gains from trade in terms of both goods, in terms of one or the other. That's why we did, you can go back and forth both ways. But it would be fractional if you end up stopping short.
Do you mind doing south? Because that's north starting point. Can you do south? It's just that 1-1.
Yeah, I wish I had.
It'll be 2 now.
Or 2 and 2, okay.
Yeah,
Okay.
still be 2 and 2.
No?
So
Yeah, it's the south last 2 hours.
the only thing that's changed for the South is the price, right? They were getting something different before. So for the South, they're at 2 and 2, but they're at 1 and 1.
Yeah.
So 1, 2, 1, 2. There's their current point. Oops.
No.
Sorry. Right when I drew that, I'm like, oops. They're at 1 and 1. Kind of made a half here. It's doing nice little increments. So 1, 2. Their production possibilities frontier looks like this. They specialize in bread. So when they give up 1, they don't get 1, they get 1.5.
But you gotta do it.
And then if you go up to 2, they get 3 shirts. Right, so 1.5 plus 1.5 if I drew this
3 divided by
nice.
2, which is the exchange rate.
Right, so this is 3.
It's actually not an exchange rate.
So their gain
Less than divided by
their gain is 1 shirt also.
Got it.
Okay?
Exchange rate is.
So all we did is we put it in terms of shirts for each, the north and the south. Keep on all countries, moving on other countries to both areas. So, part B. They each have gains from trade of 1 now. Will a trading city develop? No. Why?
Because the gain from trade is not enough to justify losing 2 shirts for the month at least.
Okay. So the gain from trade is 1 shirt. And what is the transaction cost if it's 30 minutes? What is the transaction cost costing you? If it's 30 minutes. How about in terms of shirts? What's the cost to the north for 2 shirts? Or I'm sorry, what's the cost of an hour?
1/2 of a loaf.
So it goes 2 shirts, right?
Okay.
So what is the 30 minutes costing you?
One transaction cost. No.
Yes,
That- I don't know an hour.
one transaction runs you 30 minutes,
Yeah.
right? The gain is 1 shirt. The gain is only 1 shirt. That's what part A was. Is everybody on board that the gain is 1 shirt? That's what this graph is showing. That's what this graph is showing. All right. So now, there are scale economies in exchange, and a transaction takes 30 minutes to execute. So if it takes 30 minutes to execute, what's it going to cost you? 2 shirts. So 30 minutes runs you 2 shirts. 30 minutes runs you 2 shirts because how many can you make in an hour? 4. You can make 4 in an hour, so in 30 minutes you're going to lose 2. So are you going to do the transaction? No. It's too expensive. So we're not going to have a trading city develop. Part C. Suppose an innovation in transportation decreases the transaction time. So we have the development of railroad or airplanes or FedEx or something. So suppose an innovation in transportation decreases the transaction time. What is the amount of time that's going to allow a, good, Max, yes, that's right. So it's going to be 15, right? Once we drop it down to the gains from trade, the maximum it's going to be is 1 shirt. 15 minutes is 1 shirt. So as long as it's less than 15 minutes, we got ourselves a market.
1 hour we can already make back. Or we'll get what we can make on our own.
That's right.
So the second hour.
So again, that's the break-even part. So it actually have to be less than 15 minutes. That's the point Katie was bringing up with that 8-mile thing. All right.
So if I watch the video.
So that's why there's a whole thing on translog. I mean, there's a whole discipline of transportation logistics because transportation costs matter in a big way. And that's part of what we're studying here. Katie, what?
So if I watch the video, this will make sense because it's like.
Yes. Yeah, you missed a lot by missing class. Yep. You need to work through, and it's, by the way, the slides and stuff and what we did on the video is straight out of the textbook. So you'd have that as well. So you can go back and forth between all of them. All right. Wasn't that fun? How about we do another one, folks? Yeah.
Because I was here for international. And you did those. Can you
Yeah.
tell me what the difference is so I can maybe see?
The international, we didn't bring in transaction costs. That's really the only difference. So we have the gains from trade, but now we're allowing the gains from trade to be wiped out by transaction costs because there's another cost involved.
Where are these mountains that are coming? That's all.
What's that?
The mountains. Those don't make any sense.
The mountains.
Yeah, it's like the next page over. There's
Oh, we're not there yet. We're not there yet. Yeah, there's lots more fun to go. All right, so here we go. Consider that martini glass again. Depict graphically the effects of the following sequence of changes on the martini glass and figure the width of the factory's market area. The changes are cumulative. Don't forget. So meaning as we work through A, B, C, and D, we're going to, the changes that we make are cumulative. So we're going to start with kind of baby steps in part A. So an innovation in production doubles labor productivity in factories. An innovation that doubles labor productivity in factories will do what to the stem of the martini glass? Widen. So we're going to have a wider martini glass?
Yeah,
Okay.
because labor costs.
Yeah, why is not an option?
there is actual options, Michael. So
Oh,
So length that you're looking for?
oh, the stem.
yeah,
Short.
the stem. Yeah.
Which would,
They can do more,
Right.
so that drives down the
So
price.
Kate,
the cost
Kate's
of
got
bread.
it here. It's going to decrease the stem because
Yeah.
if the workers are more productive, it's going to be lower cost, right?
Per-
Lower cost for the business, lower cost to make it. So that's going to shorten the stem. So that's your first effect.
So it shortens it from a third to.
Shortens it from a 412, yeah.
Yeah. So what's that going to be?
Are you dividing
Yep.
it out to 2 12s?
That's right.
Nice.
4/12 to 2/12.
How's that?
Yeah, cost.
So what was our labor productivity from before?
Must have been more.
Remember what it was? It was a combination. That was the one that was a little bit slippery.
2 living,
It was 2 and 6, right? So we had the 2/6, which was 1/3, which is where we got our cost from to begin with. So we could do 6 shirts per hour. Now we've doubled our productivity to 12 shirts. And so that's what's bringing us from 4/12 to 2/12. Or, yes, ultimately from 4/12 to 2/12. So we're doubling it. Ends up having that impact on the price.
So does that mean the width doubles
Because it's
of the market area? Is it double? in
Oh,
proportion to
yeah,
what the
that's
layers?
getting to our next, you're moving on to the next one?
Yeah.
So part B, the width of the market area increases from 16 miles, remember it was this, what we have here.
So it'd be
So if we
32,
shorten the stem,
so it's
what does
64.
it zap up to?
20,
20, how'd you get that?
because you got 2/12 for production costs, and then each additional mile costs another 12, so you got 10 to 11 on each side.
So from the slope of these, by the way, this is not just a martini glass, this is actual function here. What is the slope of this curve or line? What is the slope of that thing?
Isn't it 112?
112, right? So that's equal to that transportation distance, right? So if I go 1 mile out, it increased 1/12. We go from 4/12 to 5/12. So the rise over the run, I run 1 and I'm going up. I run 1 and I go up a 12. So the slope of that was a 12.
Their productivity doesn't have anything to do with their.
Right, the productivity doesn't have, yeah, what was the 1/12 again? What was the 1/12?
It's the transportation cost.
The cost per mile for who?
Consumer.
The consumer. So yeah, that was on the consumer side. So part A, we zap the productivity. We say, hey, martini glass is going down, the stem's going down, so that's good for the business. Costs are lower, but that didn't change anything with the 1/12 transportation cost. But that, as you pointed out, widened this. But my point is that the slope of this line stayed the same.
It's parallel.
Yep. And so then you can do a little math to see where you end up, because you're gonna, the indifferent point was at the price of 1, or we start to limit the market area where we're back to home production compared to the factory production.
So what's the answer to be?
So it goes out to 20. So 10 on each side.
And we added the 2 miles because now it's 2/12.
Yes.
Goes out to 10.
So if you drop your stem on the graph, that's why you guys have the picture. I would draw that, go down to 2/12 and draw a line up. That's how that would go if you did it all nice and careful. And then you can support that with an equation. Because remember, we're trying to get up to 12/12. Right?
Which
So
is
we're
1.
starting at 2/12. That's where we get our 10 from. Remember here we went from 4/12, and then we got out to 8, right? Because 4 plus 8 is 12. 12/12 was the indifferent point. Now we've dropped down to 2/12, and we're still going up to 12/12,
So it's 10.
so it's 10. So that means your distance out here is 10, from the factory. So now we're starting to think about how things change.
What if like I understand that like
Yeah.
What equation did you get to use? What? To 10? You're going up to 1. We're on this one, right? We're going up to 1, which is 12 twelfths. So 12 twelfths minus the 2 twelfths gives you the 10. Okay. All right. Building on. Everybody's okay there? So an innovation in transportation that doubles consumer travel speeds will do what to the slope of the martini glass?
Now this is where I was jumping.
Yeah, you were kind of getting into that. So now we're going to allow the consumers to get to us faster. What do you think there?
About 40 miles.
Well, in scope.
That'd be, that's part of the EV, how you wrote it.
Oh, yeah, sorry. From 112 to 124.
1/12 to 1/24.
It's gonna be a decrease.
Okay, so yeah, what's happening to our martini glass? Is it getting, there's my, ooh, I do need both golf clubs. Are we tipping this sucker out or are we bringing it in?
Tipping it out. That's gonna be a lot more martini.
Big martini.
40 miles.
This is the jumbo martini, yeah.
So what's the area
The
of
double.
that, of that
Shaken.
martini?
Getting into a.
Shaken, not stirred. This is what?
So you
This is getting into a more
40.
Yeah, this is the jumbo marg. So again, remember the slope was 1/12, and now we're going to go over 1, and here we were going up a 12th. Now we're going to go up a 24th. Right? So those of you who are looking at the slope, this is, we go over 1, up a 12th, from 4 twelfths to 5 twelfths. So over 1, up a 12th. Now we're going over 1, up a 24th. So like you said, the martini glass is flattening out to be that jumbo mark.
we're just basically saying that the faster they go, the less it's gonna cost them.
Yes, whatever the innovation is has made it easier to get there. So it's lowering their price. Remember this one too. The person who lives 8 miles out is paying the price of the good plus the transportation cost. But now that transportation cost is less. Now that transportation cost is less.
So from 112 to 124. So we can probably expect to see one of these on a quiz or a test, huh?
Uh-huh. Yep.
I think we've got these to spend.
I'm gonna write that down.
The answers aren't in the back of the book, are they?
No, they are not.
Darn.
Okay, so we got the martini glass. Everybody's good with part C here. The slope of the martini glass goes from 1/12 to 1/24. Now, the width of the market area, part D, increases from what
Wasn't it 16?
to
I
what?
think I got this one. If you want it.
Now remember, we're building this cumulatively.
It'd be to 40.
20.
On each side.
Yep, on each side. So it's 40 width. So our area used to be 16. Then we dropped down the stem due to the productivity change. That widened us out to 20 total. And now we took that new change with the innovation in consumer, and we did that, and now we're up to 40. So 20 on each side.
Was it intermediate where we had really, really random, like, unit measures?
What do you mean by random?
I guess where we combined, I'm just thinking as far as like finding the size of the market, is it going to be like dollar miles?
Dude, there's no
Oh, well, I mean, we've already done some of that, right, with loaves per hour and
Yeah.
I mean, we've done some of that. So yeah, there might be combinations of things. Yep. That's always possible.
Thank you.
I think I need a little bit more. All right, folks. So that's your first little dose. We got more to go here. We haven't done yet. No, we're not
We
quite
got
to
25
one.
minutes.
Now I'm starting to get inebriated from all these margaritas.
Martinis?
We're gonna need some.
Yeah, you are.
He said you need some more.
All right, so the next topic that we're going to wiggle our model around with is the location orientation. Do we locate close to our customers, or do we locate close to our resources? Do we locate close to our customers, or do we locate close to our resources? Depends on the cost, okay? So, what else did you say, Chelsea?
Just the cost of input.
Okay, so input and output, what else besides that? And actually, I'm not so sure that's as important when we think about the location. So you said the cost of the inputs versus the output.
Cost of the transportation.
The cost of the transportation of the inputs, which drives the cost, right? So,
That together.
well, you got to, but that's the important pieces that we've often left out, right? So that's the little twist that we got on it. So you're right that it's the cost of the input, but it's not because we're changing the quality of the redwood forest or something that we're using for the lumber, but we're going to hold that constant. And what does it cost to get those inputs to us? So it's the transportation costs involved
The
with
things
that.
that we're selling, essentially. The inputs are the things
We're going to
we're
look at
selling.
both,
Yeah.
possibly the transportation costs associated with our outputs, or the travel costs associated with our consumers getting to our retail store, right? Do I locate there, or do I locate further away? So, in general, market-oriented firms, it's more costly to transport the output than the inputs. All right, so in our shirt example, assume we got input transport costs of 0. So we're not going to allow that to be different. So that was just like it was before. We kind of have this, oh, no big deal. We can just pick up as many machines and as many people as we want. So there's how we're going to change some behavior. And transportation is heavily correlated, the cost of it's heavily correlated with weight, right? If you go try to ship a television that's about yay big versus shipping a stuffed animal that's about yay big, you're going to pay more for the weight because there's people that got to handle it, there's trucking, all kinds of things if you're doing it by air. So we start to think about whether we're adding weight as we go through the production process or we're losing weight. Fragility, fresh food. So when we're harvesting something, as it gets transported, is it going to lose value? Hazard materials, all kinds of things to think about in terms of where we should locate. There's always going to be trade-offs.
What was the last one?
What's that?
What was the last one on that slide?
Hazard materials.
So, with this whole input-output thing,
Yeah.
the inputs are what we need to make whatever it is we're going to sell, correct?
Yep. So we're in the Mountain Dew business. We've got corn syrup, and we got the water, and we've got the plastic, and
the
then
product itself that we have made that we're going to sell. So you
once it's off the production process, we're going to ship this baby off to Hy-Vee or off to Dillon's and off to Walmart.
Just
Right?
wanted to make sure.
So if we have a material orientation, it's more costly to transport the inputs than the output. So examples of that. More costly to transport the, and I guess this is part of where I was with the with the Steinways potentially.
Why do you say that?
Well, what about shipping Steinways? How are they?
They are extremely fragile.
Easy to ship or hard to ship?
Hard.
What about on the materials that go into a Steinway? So the materials that come in, relatively speaking, what is the Steinway? Is it a weight gaining activity or a weight losing activity? Weight gaining probably, right? In terms of what we're bringing in. Obviously you got some mass things now. We got to be a little bit careful if you're, depending on how those materials are coming in. If you're taking raw lumber, big trees or something into the Steinway shop, but I'm pretty sure they're not doing that, right?
Well,
they're bringing in finished boards, maybe rough finished boards of some sort.
I'm pretty sure as far as it goes.
Do they start with a tree? I don't know. If you know
Well, they
more.
start with the wood, and
Yeah.
obviously all the wood's different. So the inputs there would be, you know,
The wood probably comes in some sort of rough form, but it's
Yeah.
still in probably boards or something, and then they refine it from the whatever it comes to. Be my guess.
Yeah, close, I guess.
Yeah, I don't know if you've seen the production process, but
I haven't seen it, but I know.
I can't
parts of it.
imagine they bring in a big redwood tree
Well,
and
the-
ship it in, and then they have a machine that strips it down into
Well,
planks.
you know,
so.
like the big piece that they have on the 9-foot grid, that's a whole single piece that
Mhm.
they've molded.
No, yeah, I'm
So-
sure they do have some big pieces. Yeah.
Yeah, the big like iron plate that they have on the inside is actually shipped in though. I do
Okay.
know that.
So those are the types of things we're thinking about. So, what are some businesses that need to probably locate closer to the inputs?
John Deere.
Okay, why?
Well, their machinery and their riding lawnmowers are massive.
Okay.
I'm just thinking probably a lot of those parts are, the motor itself is probably heavy.
Okay.
And,
Other examples?
Something that has-
Leather. Okay.
Something with a lot of waste.
A lot of waste, like you don't,
In
it's
production.
heavy to get it. So back to the tree example,
Yeah.
there's a company that ships, and I don't know this for sure,
Yeah.
but there's a company.
Whatever they ship.
The company that takes the tree, the actual
Yeah.
doggone tree that you've seen on big logging trucks, right? That goes to a plant, right? So where does that plant locate? Close to the trees or close to the Steinway place where they're going?
Steinway. It's supposed to be tree.
Close to the trees.
But
Right?
doesn't the tree
You're
company-
taking a zillion pound tree.
Right, but the factory, is they paying for the transportation costs from the tree to get to there, or are they paying for
Well,
the
just think about the cost
it's
itself.
included in the
Yeah,
cost.
yeah. So that's part of their process, right? So they got to take this big heavy tree, and when Steinway buys them, they buy them in groups of whatever, a fraction
Yeah,
of the
that's what
tree.
I'm Steinway.
So it's really a weight losing activity, right?
Yeah.
We're not making something bigger. We're taking a huge tree and we're turning it into big boards. Maybe they're pretty big for
Yeah.
whatever certain pieces, but they're not the whole tree. So that's a weight losing activity, and so that firm would tend to locate close to there. Where is Steinway located?
New York.
New York, like close.
I mean, I think it's in Brooklyn.
Okay, not too far from Manhattan
No,
and
like
all the
downtown
hot.
New
Obviously,
York.
it's an old company.
New York.
So where did they locate their sales? Close to the customer or close to the trees? Close to the customer. We got a heavy Steinway piano. So let's go to where the population is super dense and people are super rich. By the way, New York has almost always been one of the richest places in the United States. All right, so that's where I'm going to sell a lot of pianos. Let's plop the factory there. Okay, so those are the types of decisions that are going on. If we're doing canned food, that we don't have the perishing issue, right? So then we can ship it around. Deodorizing skunks. Okay. Yes.
I know you guys know this, but I worked for Target over the summer again, like
Yeah.
an internship, and I learned that their warehouses are like within, it's like a equal distance between each store. So like they have so many stores, like 1,300 stores in the nation. So
Right.
because they have so many stores, they can put a warehouse within like 200 miles of each store instead of going to where the products are coming from, which is what you're saying.
Right. And so they're facing that same type of thing of distance traveled to each store, right? So,
that-
they're where their location of their warehouse is, they're taking that type of stuff into account. Yep. Okay, so sugar beets is an example we're going to work through here on where we decide to locate. So farmers sell beets to processing plants offering the highest net price. So you're a beet farmer, where are you going to go? You're not going to process the beets themselves, right? So that's the process we're envisioning, kind of similar to some of the other things we've been talking about with the location. So, upside down martini is one way to think about this, right? So if you're a farmer that's close to the processing plant, you're going to get $40 for your beets. But if you live 20 miles away, you're only going to get 35 because you have to bring the beets to the processing plant. That's your transportation cost, right?
So it's $5 in transportation costs.
Yes. Yep. So then there's some sort of transportation per mile type thing, just like our martini glass. So we're going just the opposite here. All right, so maybe our beets go around the world. The book uses this coastline idea, so we can kind of think about where the output might be going. What's assumed in the model is that we don't care about that. That's not an important part of it, is the output, because we're the farmer providing the input. Our buyer is the processing plant. So we're kind of that place in the in the stream, so to speak. So here's our evolution of towns, called processing towns now, that build up around the processing plant. And the same thing's going on the further we get from here. All of a sudden, it doesn't make quite as much sense. We start seeing another one build up, and that sets the distance, driven by the cost and the transportation to the consumer, the farm. All those variables contribute to the ultimate distance that we are away from each other, that each one is away. Who remembers monopsony? Monopsony. We have monopoly, which is one what?
Producer.
One seller, one producer, right? So monopsony, one supplier, one buyer. So one seller for monopoly, one buyer for monopsony. We spent a little bit of time on that in principles class, not much more than describing it. But with this locational stuff, you can start to think about local monopolies and local monopsonies. So with the martini glass, at the factory, if you are selling shirts, you were kind of a local monopoly, right? Within that market area, you were the only one selling. And that's the only place it made sense. If you go outside that region in the single model, then it was easier to be self-sufficient. It didn't make sense because of the transportation costs. So we can start to think of there being these areas of local monopolies, local monopsonies. Okay.
Okay, I don't understand like the x-axis. Distant from coastline. What is that?
Well, that's why I wanted to put that up. It doesn't matter as much. I was kind of questioning why they even put that up anyway. But the beets potentially have to go out to buyers from, let's say, all over the world. Is the only thing I could think of. And so where does the very first plant operate? If there's land all around, it would be efficient to operate 40 miles out, would be kind of the center for it.
Okay. I thought it was like the coastline was like where the resources
And there would
were.
probably
Then it
be,
makes
the way this model is going, there's like one port. So it might be the coastline, but maybe there's a port or something. All of this isn't even discussed in there.
It's
but
just a truncating of where can't you now.
yeah. That's right. Yeah, that's right. It gives you a boundary of, we can't go this way because there's a coast. So how are things going to evolve? The cities are going to evolve this direction. So it just kind of created an artificial boundary.
Every 80 miles.
Yeah, that's right.
There's a
Yep.
plant or whatever.
Okay. I think we've got time to torture you with one.
You're so accurate.
Alright, so the net price of beets received by farmers decreases as the distance to the processing plant increases. The market area of the typical beet producer plant is 80 miles wide. So a system of processing towns develops with a distance of 80 miles between them. So that was what was on our sheet before. So considering that, which shows the market areas for sugar beet processing, suppose that there's an increase in the price of diesel fuel that doubles the cost of hauling sugar beets from farms to processing plants. How would you modify that figure to show the effects of the higher transportation costs?
Well, would it make it steeper about like linear?
What's that?
Like instead of the mountain being so flat, wouldn't it make it steeper?
Yeah, I think so. Let's calculate some actual numbers though.
So
But I think yes, you're on the right track.
so F goes to 80 then.
So what does it cost currently?
25 cents per mile.
How'd you get that?
The slope of the curve, or line, from 0 to 40 and 30 to 40.
Okay.
So the rise over the run.
So again, the slope here of this curve is telling you some information. So we're going $5 up is the rise, and we're running 20 miles.
No, she's gonna double to 50 cents.
So, and now it's going to double to 50 cents with the problem, right? So we had 25 cents per mile was the amount, and now it's going to be a little bit more, doubling up.
And by no means is the price per ton of beets going to go over 40. Is that correct still?
Right. Yep. That's what we have for starters. Right. So we're just going to have the per mile price changing. So that's part A, 25 cents to 50 cents per mile. If the number of processing plants remains at 3, the net price received by the farm that is most distance from the closest processing plant changes from what to what?
30 to 20.
30 to 20.
Were you on B on for A?
I was on B. So A was 25 cents,
Yeah.
from 25 cents per mile to 50 cents. And as Max said, that's going to make this thing steeper. Right, so we're going to see both of these lines. I might need to bring both golf clubs in now. I'm going to have both of these creep in. And so that part B says if it remains at 3, if there's only 3 processing plants, what's going to happen?
That was most distant.
The most distant was this guy, right? So we had the most distance was here. So we're really just calculating where does this intercept come in, right? So now we're at a slope of the 50 cents, and that'll end up coming in at 20. Yeah.
Like, I understand that, like, if that same processor that was, like, that far away, like, that's where they were still going to that processing plant. But could you have a possible effect that the width around each processing plant would become smaller to where more processing plants would grow up?
That, yes, that's getting to what would be our prediction of what would happen in the future, yes. Then all of a sudden we'd start to see probably a processing plant entrepreneur thinking, oh, well, we could locate a new plant right here. That's right. Kate, you were on the 20 to 30?
Yeah.
If we take this guy right here, the transportation cost is running $10, right? Because the $40 is what they get, but it's running them $10 of transportation. Transportation's now doubled from 25 to 50 cents, so now it's costing them 20 is one way to look at that.
Gotcha. Okay.
So we dropped to 20 you guys might have did it a different way. Did you guys calculate it a different way?
I did like it went down 10 over 40.
That's-
and then now I'm doing down 20 over 40.
Yeah. Yep. So you can work with the slope too to do the same thing. Okay. All right. Last thing for you. You need to do the rest of the questions for next week is your homework. Here is the answers as you work through them. I want you to do all of them. The tests will be based upon, guess what? These. So if you blow through them and don't really learn anything, then you will probably also blow the test.
When's it?
Now you don't have to do the ones we did in class. Those are on here too, by the way.
At least do Tuesday.
Yes, Tuesday. Yep.
So
Obviously, you guys can work on them together if you want to do little
so
study
what do we
groups
do?
or something.
1, 5, and 10. So I don't have to do 1, 5.
That's right. You do not need to do 1, 2, or 1, 5, and 10. Correct.
And as far as turning them in, do we need them to,
I thought it was 1, 2, and 3.
do we need them to be in any certain form or?
No, you can just do